So whenever I go shopping, I never go alone, or I always go in groups of two or three, but never in four. You know why? Because I don't want to be primed by all the marketing salesmen at these shopping malls. And I'm talking about the subconscious, how the effect of priming on our subconscious, which reacts to all these tactics. So as an example, like when they did some study on a bunch of customers that were walking into a computer shop to buy a laptop. To half of them, they asked like, "What are your memory requirements?" And to the other half, they asked like, "What are your budgetary requirements?" And what they observed was that the people that were asked about budget ended up buying cheaper laptops, and the people that were asked about memory ended up buying laptops with more memory. And it's a statistically significant result. And priming in psychology has wide-ranging impacts in economics. If you've read this book by Daniel Kahneman, Thinking Fast and Slow, would totally recommend that. Talks a lot about these effects and how we make economic decisions. Anyway, I don't want to digress more. Welcome to another week of Coding Interview Weekly. And if you're wondering what this is all about, I just propose some problem on LinkedIn and a bunch of people discuss it, and then I post an insight video about this problem, which is a typical interview problem that you may see in Google interviews, and then I provide insight from the other side of the table, like how do interviewers think, what are we expecting, what are the common pitfalls, and meanwhile, I also want to talk about the fundamental ways to approach that problem, to problem solving as well. So let's get started. And okay, that reminds me, go check out lalitkundu.com. That's where I post the previous week's problems and their solutions, as well as some follow-up reading material and some follow-up interview questions that may be asked on that topic. So that will help you build an expertise in one of those topics, such as graphs, strings, and so on. So this week's problem, let's look at it. It's pretty straightforward to state, at least. It We are trying to find the smallest impossible subset sum. So given a set of integers, you can choose a non-empty subset of that array, and you basically sum up all the elements in the subset and you get a subset sum. What we are trying to find is an integer which is not possible to form using a subset, and we're trying to find the smallest such possible integer. So in this example, as you can see, if you take 1, 2, and 5, 1 is possible, 2 is possible, just take the element 2. 3 is possible, take 1 plus 2. 4 is not possible, and that is our answer. Before that, I want to address one of the questions that people have been asking me a lot, is if you've heard a problem beforehand, should you tell the interviewer, and how should you tell the interviewer? As an interviewer, I really appreciate the honesty, but never go assuming what I'm going to ask you and what I'm trying to judge you on. So if you look at this problem and you're like, oh, I've heard this problem, without explaining more how you think you have heard it and like what the solution you have in mind, I would never know that you've actually heard the follow-ups that I'm going to ask, or just like a version of this. So this sounds like a really straightforward dynamic programming problem, but there's so much more to it. And as an interviewer, I would often not change the problem when you mention that, but instead try to figure out whether you actually understand the problem, or just you have solved it, or you have read a solution. So reading a solution versus internalizing a solution, there's a lot of difference. I can often spot that, and I'll tell you how as I go through solving this problem throughout the video. So, but if you've heard it, just say that, okay, I've heard a version of this problem which goes like that, and we try to solve it via dynamic programming. And I would say, okay, why don't we just try that and see? Because I often have follow-ups which are usually not present on the internet or something. Okay, let's jump to this problem. Uh, I want to quickly go through the dynamic programming solution once, just to make sure that people, like everybody's on the same page. That goes like we define a function f of I comma j, and mind you that this is a good approach to start with in an interview. You don't directly jump to the correct solution, as I've been mentioning all along. You say that this is true or false, and it basically denotes if it is possible to form a subset sum j using first I elements of the array. And you recursively define this function as an OR between two subproblems, and the first one being, is it possible to form j without using a of I? What is that? That's a comma? Okay. So you are basically going to form the same subset sum using I minus 1 elements. Or you are going to use a of I in your answer, which means you're going to now form a subset sum of j minus a of I. If any of these two conditions is true, that means it's possible to form a subset sum of j. Um, the time complexity is pretty interesting. I would ask that if the candidate comes up with this. It's for dynamic programming solutions, we know that the time complexity is the number of distinct states multiplied with the transition cost. So transition cost is basically from one certain state to calculate one certain state. If you have all the sub-problems available, how much time are you going to spend combining them to build an answer for current state, which in this case is constant time. Basically, you're taking an OR between two integers. Um, and the total number of distinct states is total number of different values for I, which is n, and total number of different values for j, which is s, where s is sum of all integers in the array. So I expect like a good candidate to basically be done with this like in 5 minutes or so, because this is a very classical dynamic programming problem, and any fundamental computer science course talks about this. Any fundamental algorithms course will talk about this. And even if you haven't taken the course, I mean, it would be really amazing if you can come up with this by yourself or even by memory. Maybe you've read about it. Maybe you've read the Wikipedia article or something. In any case, this if this is taking too long, that means we are stuck up on something which is at the base. We have to move on. And in any case, I would say that let's just scratch this approach and try something else. So the time complexity of this is order of n into s. All right. I'll talk about more about this time complexity later as well. Now, let's try to see what's so special about this problem. How can we do better? The thing to observe is that we are not trying to solve the general subset sum problem, which is basically for any arbitrary sum, arbitrary integer, you try to say whether it's possible or not. You're trying to find the smallest impossible subset. There must be something special about that. And there's one really fundamental observation that is required to solve this problem. And once you hit that, it's pretty easy after that. So say your answer for a given array is s, basically all integers from 1 to s minus 1 are possible, and then s is not possible, and then we don't care about others. Some are possible, some are not, and so on. The observation is this: if I add an integer uh, greater than s to the array, does my answer change? Let's see. So I added s plus 1 to the array, which is um, greater than all elements of the array, let's say. It doesn't even matter actually if it's greater than all elements or not. Let's say we added an integer which is s plus 1, which is greater than all the elements in the array, right? So what are the new possible combinations? Well, s plus 1 is possible, and then I can combine with any of these. So s plus 2 is possible, s plus 3 is possible, and so on. So our answer is not changing in this case, right? And that's our hint that we need to process the array in an increasing order to say something about it, to say what the answer is going to be. So it will look like this. When you start processing your array in an increasing order, or say non-decreasing order if you have duplicates, it will look like this. First, you will have all possible subset sums from 1 to k1. You add another element, you have all possible subset sums from 1 to k2. You add another one, you have all possible subset sums from 1 to k3. And then comes a stage when the all possible subset sum starts breaking down into intervals. So it would start looking like this after that. And once you reach this stage, your answer is not going to change. Your answer is basically this integer. And that's it. This is it. Now you start processing your array. And let's say you have processed I elements up to this stage. This is like A1 to AI. You've processed all of them. And your answer is K2 plus 1 right now. So now you're trying to add K to this array. And note that K is greater than all of these. So there are two scenarios that can happen. The first scenario is where the possible subset sums are going to break down into intervals. And that happens when k is greater than k2 plus 1, right? That will lead to a scenario like this. Basically, k2 plus 1 is not formable, is not a possible subset sum, and that's your answer, and you stop there. No need to even go further. The other scenario is where k is not greater than k2 plus 1. In that case, we have to reason with what are the possible subset sums that can be found by using k. So we can form k, just use it by itself, and then we can take any integer from all of these which are possible and add it to k and form a new possible subset sum. So we have possibilities which are between k and k plus k2. And basically now that is our new interval that we are operating on. So k3 is now k plus k2. So that's it. Now just sort the array, traverse over it one by one, figure out which one of these scenarios it's gonna be, and stop or keep going. And I mean, like, I want to run it with an example so that it's more clear. Let's say you have 1, 2, and so on. Let's say, so the first, if you take 1, what's possible? 1 is possible. If you add 2, 1 to 3 is possible, right? Now, let's say you add 4 to it. So in that case, all integers between 1 to 7 are possible because 4 is not greater than 3 plus 1, right? And now let's say I add 9 to it. We see that 9 is going to start here. So it's going to break down now. So 1 to 7 is possible. And then it's going to be like 9 to whatever. We don't care. Once it's just broken down. And this is our answer, 8. So this is our polynomial time solution for this problem, and the time complexity is order of n log n, which is certainly better than the DP solution. And unless, yeah, it's unless s is less than sum of integers is less than log n, which is which can't happen, right? Log n is the number of bits, and if you're going to add it, if you are going to sum some integers, it's at least gonna be the number of bits. Actually, it can represent a smaller sum as well, but this is just like a very corner case. Like this is not a generalized situation. This is very specific. So this is the thing. If you had known this problem and if you knew the solution, explaining it via the fundamental approach is going to be harder. Like, okay, I'm just going to sort it and then I'm going to do this, this, this. But if you directly come up with that and not be able to explain why it works, it will give me a hint that it's okay. I mean, you know the answer, but you don't know it fully. So you're still coming up with it on your own. There's a very interesting follow-up to this, which I usually would ask if candidates finish this in like 15 minutes, and then code is like should take like 10 minutes. I mean, it's a pretty straightforward code, nothing complex, no complex data structures, just a for loop. The the follow-up is like this. What would be the for all I from 1 to n, tell me the answer if a of I is removed from the array. Okay, think about it. It's based on the same approach, but slightly more complex for maybe for candidates that are really good. So once you reach this stage, after this, you keep removing whatever elements from the array, the answer is not going to change. But before this, what may happen is, let's say you removed two. Let's say you removed two from the array. In that case, a possible break may happen. There may be a possible break up of this contiguous interval if you remove two. In that case, the answer would change for two. If that does not happen, what would happen to let's say it still goes like this. There's the possible break doesn't happen, but the eventual answer will be a little bit less. And little bit less by how much is what this question is about. So think about it. I'm not going to go into the details of that, but that's a pretty interesting follow-up on that. And now actually coming to the follow-up that I've mentioned here. uh, I mean, it's basically asking the answer for any arbitrary integer x, whether it is a possible subset sum. And that is what the subset sum problem, the NP-complete problem is about. And I just want the candidate to reason with it once and see how much deep are they in the waters of computational complexity theory. So a question may arise right now, like, oh, do I really expect candidates to have a good theoretical hold over computer science? I would say if they have a CS degree and they have done an advanced algorithms course, they would probably know about the set of NP problems, NP hard and NP complete problems. Otherwise, it's okay. I'm not looking for a deep understanding, at least for these, for let's say junior engineer, software engineering interviews. It's not a requisite per se, but still, I think it'll be good to understand that that solution we had for via dynamic programming, it's not actually polynomial, but pseudo polynomial. An algorithm is defined as polynomial when it's polynomial in terms of the size of the input. Size of the input in this case is the number of bits in the input, and the number of bits in S, if that is the size of our input. But S is actually exponential in terms of the number of bits, and hence This is basically still a pseudo polynomial algorithm, and subset sum problem is one of the hardest NP-complete problems. And if just a reminder that the problems are called NP-complete if uh, their solution is verifiable in polynomial time. So let's say I give you an answer, you can basically sum it up and say whether it sums up to x, and that's polynomial time. Uh, and like every problem in the NP set can be reduced to NP complete problems, and these are one of the hardest problems. So anyway, not going too deep into that. I just wanted to mention that having an understanding of that is really good. But at this point in the interview, it's just going to be a theoretical discussion about what are the possible ways, what are the realistic ways to solve these problems, like approximate, randomize, stuff like that. I won't say I would penalize someone who's not too deeply aware of the complexity theory. So that's that. The next week, I'm gonna post another problem pretty soon, so keep an eye out for that and feel free to provide feedback. I most certainly would have made some mistakes in the video. Feel free to point those out and see ya.